So I have already showed you the project introduction and NLP pipeline, like how to create an NLP pipeline and all. I have given each and everything overview. Then I also showed you the project setup and utility module yesterday only. So we have seen like how to create the project template, then how to set up the requirements, how to configure GCP, okay, how to upload the data, okay. Then I have already showed you how to write the login exception, and I have already given you the project overflow workflow idea, okay. Now see, we can start with the implementation. It's completely fine, but what I need to do actually, first of all, I need to do something called notebook experiment, okay, notebook experiment. Need to perform notebook experiment because I think most of you are already familiar with something called Jupyter Notebook implementation, or let's say Google Colab implementation. But when it comes to like converting this Jupyter Notebook or let's say Colab Notebook to the modular coding, you will face the difficulty level, right? So instead of directly jumping into the modular coding, what I will show you, I'll first of all show you the notebook experiment part, like the way we used to perform any kinds of project, okay. So we'll be analyzing the data, we'll be cleaning the data, okay. Then we'll be training the model, saving the model. So these are the thing actually we'll be performing on the Jupyter Notebook. So once this Jupyter Notebook is working fine, okay, if it is working fine, everything I'm getting as expected, then I will start my modular coding, okay. Then I will be like separating this notebook in a component, actually separate component. What are the component, guys? I think you already saw. So these are the components. So if I go to the head components, so these are the component: data ingestion, transformation, evaluation, trainer, pusher, okay. So different component will be implementing. Got it? Yeah. And this is an NLP project. I'm going to use something called LSTM network. First of all, I will show you the GPU training. Okay, like if you don't have, let's say, GPU in your local systems, what you can do, you can try on Google Colab. Okay, so Google Colab provides free GPU, so there actually you can train the model just to do the experiment. Okay, but whenever you are creating the pipeline, so definitely if you are doing real-time projects, you will be getting a GPU server. Okay, there actually you need to code, but here actually we are doing everything in our local. If you don't have GPU machine, it's completely fine. Still you will be able to train, but training would be a little bit slow, okay. So both way I will show you, you can do it. Here also I can perform. Here I can also create a Jupyter notebook. Here I also can do the coding, but I'll show you the on the Google Colab, okay. Then I'll try to bring that notebook here, and you can also execute here. It's completely fine. Okay, so the first thing what I will do, guys, I'll just a minute, my mouse is not working. Yeah. So first of all, I'll just try to open my Google Colab. So here you can write collab, collab.research.google.com. Okay. So if you just search it, I will able to see your Google Colab. Okay. See, now here I will take a new notebook. Can we do in the collab instead? You can only perform the experiment part. Okay. Not the entire pipeline. Okay. Let me change my view. I think it should be visible. Yeah. Now guys, can you see my screen, or should I zoom a little bit? I think it is visible to everyone. So here I can name uh, experiment experiment.ipynb. Okay, so let's say this is the name I've given. So the first thing what you can do, guys, first thing, just change the runtime. So change the runtime type to GPU. So here if you're using free collab, you'll be getting T4 GPU, but let's say if you're having collab pro subscription, you can also access A100 and V100 GPU. Yeah, runtime GPU we need to select. Okay, now click on save. Now let's connect the notebook. Now left hand side, what you can do in the storage, actually this collab storage, you need to upload your data. Okay, so once it is connected, I will upload my data. I think data I already shared with you guys in the GitHub. Actually in the data folder you will see the zip file. So try to download this zip file and try to upload inside Google Colab. How to upload it? I think you know that. What you can do, you can just open it up. Okay, so let's say this is my zip file. So you can just drag and drop here like that. See, left hand side my data is uploading. So let's wait. So once it is done, I'll start the coding part. So you can also do with me. And I will also share this notebook with you. Okay, no issue. See, my data is uploaded. Now the first thing what I need to do, I just need to import some of the library, and I will unzip the data and I'll try to use it. Just a minute. Yeah. So first of all, let's unzip the data. Okay. So how to unzip the data? But before that, let's check out GPU, whether I got GPU or not. So you can write this command, NVIDIA SMI. So it will give you the GPU configuration you got. See, I got Tesla T4 GPU. That means everything is fine so far. Now the first thing, I need to unzip this particular data. So for this, you can execute this command, unzip, unzip. Now you can give the name, or you can copy the path of the file, and you can execute. Now see guys, I have done the unzip. Now see, these are my CSV file I got here. Imbalance underscore data CSV and raw underscore CSV. Okay, why I have taken two CSV file? Why I have taken imbalance data set? Because let's say if you are facing imbalance kinds of problem, okay, during let's say if you're doing any kinds of NLP task, how to actually resolve these are the issue. Okay, so that's why I picked up this particular data set. So first of all, I'll load this imbalance data set and I will show you the data is imbalanced. Okay, if you see like I think their hate label this one abusive text actually is like very low there. Okay, so we need to handle this part actually. I'll tell you the level. Okay, what are the levels actually you have less in the data set. Fine. The first thing, I'll import the pandas. So import pandas, uh, pandas spd. Then let's load this data. Yeah, so now I can load this data. So this is imbalance data, so I'll just name it as imbalance 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 bl. Okay, imbalance data, let's go data. So pd dot read csv, read underscore csv, and here you just need to pass the imbalance data path. So this is my path. Now here what I can do, I can execute and I can show you my imbalance data. So if I just write data.head, so it should print the data. Okay. Now guys, see, this is the data. Now can anybody tell me hmm, in this data actually what are the columns I need? Yeah, hi Nirav, hi. Yeah. So in this particular CSV data, what are the columns I need here? What do you feel like? What are the columns are important? Here I am having ID, label and tweet. So what are the columns actually you will be picking up for this project? Let me know. Label and tweet. Yes, you're correct, because tweet is my hate speech. Okay, and with respect to that actually here I'm having the label. Okay, whether this tweet is hate speech or not. So I don't need the ID actually. ID is extra column, so I can drop this column. Fine. Now let's do some EDA on top of this particular data. Okay, like here I'm calling this data as imbalance data. Okay, why it is imbalance? I think you know how to identify imbalance data. So let me show you. So here I'll just perform some EDA operation. So let me just write EDA. EDA. This means exploratory data analysis. So here, first of all, let's import one library called cbon. Okay, so import cbon, cbon as SNS. You can also use matplotlib, it's completely fine, but I will be using cbon. Now here I'll just plot one graph called counter plot. Okay, I think you have heard of this counter plot. So cns dot count. Okay, count plot. So here you need to give the label. Okay, the first thing you need to give the label. So x is equal to. So what is the label, guys? This is the label. Okay, and the second thing you need to pass the data. So this is my data, imbalance data. Now if I execute this particular code, so it will show me the plot. Now see guys, what you can see, what you can see from the data. So here you can see, here I'm having the zero label. Okay, so here zero means, let me just write down here, zero represent no hit. Okay, and one represent hit. Okay, I can give just a minute. Hmm. So here what you can see, guys, data is imbalanced, right? Because here I can see zero label I'm having more than my one label. That means I'm having no head data, more in my data set, but head data I'm not having. Okay, more data. So now what I need to do, I need to handle this kinds of imbalance problem. Otherwise, what will happen if I'm using these kinds of data set, and if I'm training my model will be what? My model will be biased, right, towards this zero. That means to no head. So if you are giving any kinds of, let's say, text, it will predict as no head because it has been biased actually. Got it? Okay. Now let's also check the shape. So imbalance data dot shape. So let's see how many record I'm having here. So here I'm having 31,962 records. Okay, and 3 columns. Now let's check whether I'm having any missing value or not in this particular data. So you can just check it by using this is null function, is null, and here you can write dot sum. See, I'm not having any kinds of missing value. That means everything is fine. So now what I can do, I can see this ID is not required, so I can drop this ID column. Okay. So for this, what I can do, I'll just call my data, and here I'll just write drop. I want to drop the ID column, ID, and here you need to specify the axis. Okay, axis is equal to 1 because I want to like drop the column. Okay, not the row. That's why 1. And here you need to specify the in place is equal to 2 because I want to do it as permanent. Now if I execute and if I again print my data dot head, so you'll be able to see these IDs has been removed. Okay, I don't have any ID here. Hmm. Now let's load our raw data. Okay, because we have seen like in this data set I'm having imbalance problem. Now we need to balance this data. Okay, how to balance it? So what you can do, first of all, you can find out any other sources of the data. So what I have done actually, I again research the data. Okay, these kinds of tweet data, and I got this data. So this data is also having hate speech and no hate speech data. So now what I can do, can I picked up this no hate speech column? Okay, sorry, hate speech column from this particular CSV and merge it inside my imbalanced data CSV. Can I do it? So let's say what I'm trying to say. Let's say I am having two CSV. Okay, I'm having two CSV file. So let's say this is CSV1. Okay, this is CSV1 and this is CSV2. See, this is CSV2, or else I can write here CSV2. Okay, so here I can see this is the imbalanced data. Okay, this is the imbalanced data. Okay, here I'm having let's say this is, let's say, this is your one, sorry, this is your 0, and let's say this is your 1, this is your 1. Okay, that means 0 like label I'm having more in this particular data, and 1 label it is like very less. But inside CSV2 I can see this 1 is having more here. Let's say this is 1 and this is 0. Okay, that means 0 means this is no head, and this is means this is head. So this is head, this is no head. Now can I use this column actually and merge it here? Can I use this column and merge it here? Yes or no? Because I can see CSV2 contains my head data. Okay, that means head label. So what I need to do, I need to pick up those data. Actually, I need to merge with my CSV1 because here 1 label I'm having less. That means head label I'm having less. Okay, so that is what actually I need to perform. Okay, so if you can find this data source anywhere, you can download the data and you can take your required data, actually whatever data actually you need in this case. This concept is clear, guys? Yes or no? How to handle the imbalance data here, because here you can't do the random assumption. Okay, so because it's a text data, but let's say whenever we are working with the numerical data, we can perform, let's say, lots of missing value technique, but here it won't be working. Got it? So that's why I need to follow this step actually to handle my imbalance problem. Now let's load our raw data. So raw underscore data, raw data. So again, I'll use pd dot read csv, read underscore csv, and inside that I will give my raw data path. Oh, raw data path, copy path, and here I will give it. Now if I show you my raw data, see, this is the raw data. Now one thing you need to handle inside this raw data. Okay, now tell me what are the columns actually you can consider from this raw data. Text augmentation is a different thing, Lincoln. Okay, augmentation is a different thing. If you are having less data, that means you can perform augmentation, but here you have an imbalance problem. Okay, one particular level you have very less, how you will do the augmentation here, right? First of all, you need to handle the imbalance problem, then you can perform the augmentation. Before augmentation, your uh, like level should be equal. Okay, yeah, yeah. Hi Imran, hi. Fine. Now tell me which column I can take from this particular raw data. Can you tell me? I can take this one to it, and I can take the class, because class is nothing but your level, and everything I can remove. What do you feel, guys? Because I'm already having class. Okay, I don't need these are the things separately, because they have done one not encoding and they represent like that only. Okay, if I'm having to it and class, I can handle this thing. Now let's print the shape of this data also. So here you are having 24,783 and 7 columns. And if you want to check whether you are having any missing value or not, the same code you can execute dot is null dot sum. There is no missing value. Now I can drop these are the columns actually. Okay, these are the columns is not required. So how to drop the same code? I think you remember. So you need to drop this particular column. See, here I've written raw underscore data drop, and I'm dropping these are the column: unnamed, count, hate speech, then offensive language, then neither. Okay, so these are the column actually I'm dropping, as you can see. Okay, now let's drop and let me show you. Is the class yeah, I need to make it as similar. Okay, how to do it, I'll tell you. Okay, first of all, let me clean up this particular data and let me show you, then it would be clear. Because in raw data I'm having three classes. Okay, let me show you what are the three classes I'm having. Now see, I'm having tweet and classes, but previously what I had, guys, I had tweet and label. Okay, so I need to bring the format like that only. I need to bring the format like that only, tweet and label. How to do it? Let's do it. See, this is your like completely data analysis part. Okay, let's say as a data scientist or as a NLP engineer, you need to analyze the data, you need to bring to the specific format. Okay, for this you can use any kinds of tools and technology. It's completely fine. Okay, now if you want to check how many unique class you are having in this raw data, so you can call this unique function on top of the class and you can print them. See, I'm having three unique class, 2 1 0. Okay, 2 1 0, and if you want to visualize them, you can also visualize. See, you can again you can like call this cbon and count plot. You can give the label, that means your x, and here you can provide the data. Now if I show you the plot actually, see, Here I'm having three class, 0, 1 and 2. Okay, now let me write down each and every class. Okay, here. So here if you see, this 0 represents, so let me just comment here. Here if you see, 0 represents head, then 1 represent abusive, and class 2 represent head. Okay, now what is the common thing you can find out from here, guys? What are the common thing you can find out from these three class? Can I call this 0 and 1 are similar class? Yes or no? Can I call this 0 and 1 similar class? Yes or no? Hate and abusive. These two labels are similar. Please let me know. Yes. So can I merge them together? Can I merge them together? So let's say here I can see I'm having hate and abusive, but hate I'm having less than my abusive. So what I will do, I'll take this hate also and I will merge them together. Okay, with my abusive. So I will get one particular class called hate. Okay, I'll just name it as hate. Okay, and what is 2, guys? Here 2 is no hate. So now just try to relate here. So try to relate with my previous data. So what is 0 here, guys? What is 0 here? Let me know. What is 0 here? 0 means no hate. Now can I merge this no hate with this particular column? 2 column? Yes, because here I can see 2 is a no hate. And can I merge these 2 column together? Okay, and I can make one class called hate. And can I merge this hate column with this particular column? With my 1? Yes, because here I can see 1 is the head column. Now if I do it, can I handle the imbalance problem? Because if you do it, you will see your head level will increase here. Okay, so how to do it? Let me show you. So for this, first of all, I need to let me show you. First of all, I need to copy. Let me just write down the comment so that later on you can get a reference. So first of all, I need to copy the value of the class 1 into 0, because here I can see class 0 and 1 are the similar. Okay, so I need to copy all the value. Okay, all the value of class 1 into 0. So let's do it. How to do it? So in pandas, I think you saw this logic before. So here basically what I'm doing, I'm copying all the 1, okay, into the 0. So this is the logic here I've written. Now let me execute. Okay, it's done. Now what I need to do, if I show you my data, okay, see, this is the data. Now if I show you the unique column, sorry, unique label, so still I'm having 3 unique label. I need to drop it. Okay, now but before that I need to assign the label uh, value in the 0 class. Now what I will do, I'll just replace this 0 with 1. Okay, replace 0 with 1. Now if I plot my data, okay, that means I'm having 2 and 1. Now if I plot my data, you will see I'm having 2 particular class. Now see, now I have successfully merged. Okay, see, now I'm successfully merged. So what I have done, just a minute. So what I have done, I've just copied all this one label, okay, into my 0. Okay, and I named this particular 0 as 1. Okay, so that is what actually I'm doing here. Got it? And I'm having 2. That means this is the no hit. Okay, no hit label. Now can I represent this no hit with 0? Yes or no? Because if you see my previous data, so what was the label of no hit? It was 0 only, right? It was 0. Now here it is 2. So I need to bring it to 0. Okay, because I want to match with my previous data. Fine. So how to do it? So let's do it. Here you just need to only rename. Okay, or you can do the replace operation inside pandas. See, here I'm calling class dot replace. You just need to replace 2 with 0. Okay, and in place is equal to true. Now if I execute, And again, if I show you my data, see, now it is done. Got it? Okay. Now, one thing I need to do, I think you remember, if I plot my imbalance data, let me show you. If I plot my imbalance data dot head, so these are the column name. I'm having label and tweet. But if I show you my raw data dot head, so here if you see, I'm having tweet and class. So I need to change this class to label. Okay, and how to do it? Again, you can use this rename function. Okay, rename function inside pandas. Okay, and here you can tell I need to change the class with label. Okay, and in place is equal to true. Now if I execute, and now if I show you my raw data, now if I show you raw data, now guys see, now this data and this data similar or not? Now can I merge? Have you learned like merge operation in pandas? Yes or no? Do you know what is the merge concept? If you want to merge something, so uh, like what are the things you need to follow? Let's say you want to merge two data frame together, so you should have the same column name. Okay, otherwise it won't be happening, right? Now can I merge these two data frame together? Because I can see this is also having label and tweet, this is also having label and tweet. Now can I merge it? How to merge? Let me show you. So let's say this is my df1, this is my df2. Okay, df1 and this is df2. So I need to merge it. Why I need to merge it? I need to merge it row wise. Here I will be merging. So after merging, what will happen? So this d2 will come here. Okay, this d2 will come here. Df will come here. Df2 will come here. And the same column name I'm having called tweet and label. Got it? So this is the merge actually we'll be doing. This row wise merge, not a column wise merge. So now let's do it. How to merge? Let me show you. Two data frame I need to merge together. See, that's how you can do the merge operation. Um, Here, first of all, I'm creating one frame list. So here I'm having imbalance data and raw data. Then I'm calling pd.concat. Okay, then I'm giving the frame. It will do the merge operation. Yes, concat function you can use. Now if I show you my data, so this is the final data. And now if you see the shape of the data, so this is the final shape. Got it? Now this imbalance problem has been resolved. Okay, now let me show you. So if I again visualize my data with respect to the level, now see guys. So I almost handle 80% of the imbalance problem. Okay. Now see, you have the partition of the data 180. Okay, 180. Now can I use it? Can I consider it has resolved my imbalance problem? Because 180 is not a big deal. Okay, if you have less than 50% data, we call it as imbalance problem. But if you are having almost 80% of the data, okay, in a particular level, you can consider, okay, you have almost handled this particular imbalance problem. I think you have learned this thing in your machine learning. Okay, I'm not going inside very depth. Yes, you can also do it on neural lab, but I think neural lab it is under maintenance right now, so maybe it won't be working. So guys, please give me a confirmation this part is clear so far. Whatever I have explained here, it is clear or not? Have you understood like how to handle the imbalance problem and how to concat our two data frame together? Yes or no? Okay, fine. Okay. Now we have resolved our imbalance problem. Okay, now what to do? Okay, now what to do? I need to do. I think you remember yesterday I was discussing. We have something called pre-processing. Okay, pre-processing step. So pre-processing step, pre-processing. Here I can only write pre-processing. Okay, pre-processing wise, what I need to do? I think I have listed down some of the pre-processing like lowercase operation, steaming, lemmatization, then stopwatch removal. I think you remember, right? In our first introduction session, I already written down all the pre-processing step you need to perform. Okay, so I'll be performing one by one all of them. So the first thing what I need to do, I need to first of all I'll be importing something called NLTK library. Okay, so let me import NLTK. So let me import NLTK and regular expression, because these are the library will give you the functionality to pre-process your data. Okay, so let me import them to I mean all together. Then the first thing I need to download my steaming and stopwatch, because if you're using NLTK, so you need to download this thing. Okay, so this is the steamer. So I'm using something called snowball steamer. Okay, and here I'm working with English text. That's why you need to select the language. It is English, and I'm also downloading the stopwatch. Okay, and I'm loading it. Okay, now see, this is your stopwatch. So these are your stopwatch actually. Okay, these are your stopwatch. So these are the stopwatch I need to remove from my data, because again here we're doing the classification problem, and I don't need all the stopwatch here, because I think I already showed you one example. Remember that book review example. So to classify that book whether it's a positive or negative, I only need some of the, like, let's say good word, okay, or bad word. I don't need all the stopwatch and all, because if you give the stopwatch it will increase the context length. Okay, and if you're using some, let's say, a simple algorithm, okay, so sometimes it will fail. But if you're using some let's say powerful algorithm, let's say transformer based algorithm, at that time context length should be bigger there, and at that time you can keep those as the stopwatch as well. It's completely fine. Depends upon your analysis, what particular algorithm you're using and how you're designing that thing. Fine. Now here what I have done, I have written one function, data cleaning function. Let me explain this particular function what I have written here. Now see, all the like pre-processing step I discussed, okay, in my introduction section. So everything I have written here. See, first of all, what I am doing, whenever you will be giving your data, first of all it will apply the lowercase operation. Okay, after that what it will do, it will handle these kinds of HTML tags and all. Okay, if you are having any HTML tags or bracket and anything, it will like clean those are the thing. Then if you are having any kinds of URL, okay, inside your data, it will also clean it. Then if you are having, let's say, some emojis and tags, so it will clean it. Okay, so that's how I have written. See, this is for the punctuation handling. Okay, and after that I'm handling the stopwatch. If you are having any stopwatch in the data, it will remove the stopwatch. Then at the end actually I'm performing the steaming operation. Steaming means it will bring all the verb to root word. Okay, instead of taking different word, it will take the root word. Then it will finally join all of the data together and it will give me the clean text. Okay, it will give me the clean text. Fine. Now let me show you. Let me show you one example. So here what I can do, I can show you one example. So let me print one column. Sorry, print one row. So let's say I will print one tweet here. So let's say this is tweet one. Now inside the tweet, can you see I have @ sign, I have exclamation mark sign. So many things actually. Okay, I need to clean this particular data. How to clean it? Now if I pass this particular data to my data cleaning function, see, it will return me clean data. Now let me show you. So I will apply this clean function on top of my entire data. So this is the code for it. So here I'm telling I need to apply this clean function on top of my tweet. Okay, and I need to replace inside the tweet, because I want to replace. Okay, I don't want to create a copy. That's why I'm calling 2 times, and here I'm calling apply, and here I'm giving the function called data cleaning. Okay, now it will automatically take up all the tweet, okay, one by one, and it will clean it and it will store inside my tweet column. Okay, now let me execute and show you. Okay, string is not defined. I need to import string, I think. So here I can import string. import string. Now I think it should work. So it will take some time because I'm having that much of row. I think you saw this is the final row size, 56,745. So it will take some time. See, done. Now let's say if I print this tweet one again. Okay, now see. Do I have any problem with the data right now? Tell me. Or it is completely cleaned. See, this is the previous tweet and this is the after cleaning, after performing the cleaning operation. Got it? Okay, now what I will do, I'll just store my tweet and label inside x and y because x is my independent variable and y is my dependent variable. Got it? Now what I will do, I'll perform something called train test split operation. Okay, because you need to divide your data to the training set and testing set. For this, I can use sklearn train test split function. Okay, I think you use this particular things actually from sklearn train test split, and here you need to pass your data. So this is the code. So here I'm taking my x train, x test, y train, y test. I'm calling this function, and I'm giving my data x and y, and I'm also assigning the random state is equal to 42. So you can give any number. It doesn't matter. Now here I'm printing the length. Okay. Now let me show you. See, this is my x train and sorry, this is my x train and y train. Yeah. So that means the same number. And this is my x test and y test. That means the same number again. Okay. So we have done the train test split operation as well. Hmm. Now what I need to do, guys, I need to do the feature engineering. Okay, text processing is done, then I need to perform something called feature engineering. Now can anybody tell me what is feature engineering? I think I already discussed inside my introduction session. What is feature engineering in text? Data augmentation, text, see, text preparation, that means processing we have done. After that, feature engineering. Now tell me, sir, I can't access your neural lab when I created I kinds of message access denied. See, neural lab is under maintenance right now, so you won't be able to do it. Okay, Lincoln is telling converting to vectors. Okay, tokenizer embedding. Yes, you are correct. That means now I have my data in an English text form. Okay, but I can't give this data to my model. Okay, but because model is what? Model is a mathematical algorithm, right? So what I need to do, first of all, I need to convert the text to vector. I need to perform something called vectorization. Okay, I need to represent the number. So for this, I will be using feature engineering techniques. So there are so many feature engineering techniques I already written here. TF-IDF is there, bag of what is there, one-hot encoding is there, what to wake is there, embedding layer is also there. Okay, then different embedding models also there. Yeah. Okay, so you can use any of them. But here, what I will be using something called embedding layer. Have you heard of this Keras embedding layer before, guys? Keras embedding layer. Keras embedding layer. So with the help of this Keras embedding layer also, we can convert our text to number. See, embedding layer. Inside Keras, we have embedding layer. Okay. So by default, it will train. Okay. By default, it will train and learn during training. Okay. This embedding layer. Because I'm expecting you are familiar with these are the concept at least. Okay. I'm not going to explain this thing. So what is the use of this Keras embedding layer? It will like in take as take what it will do. It will take the your data and it will do the embedding representation. That means vector representation of the data. Okay, but before passing to the embedding, okay, before passing to the embedding, what you need to do, you first of all need to do something called integer encoding of the data. Okay, how to perform integer encoding of the data? So let me show you. So first of all, here is the code. I already prepared. Let me just explain. See, here is the code. First of all, you need to apply the tokenizer. So I need to, I think, import the tokenizer. Let me just import. Just a minute. Mm, Tokenizer. Yeah, so tokenizer is available inside Keras. Okay. Then I also need to import something called pad sequence. Pad sequence. Yeah, this is the pad sequence. Okay. Then anything else I need? Tokenizer, pad sequence. Yeah, I think these are the thing I need. If I need anything, I will import. See, first of all, what I'm doing, I'm just assigning my max words. Okay, max word. That means I'm telling inside the entire corpus. Okay, inside the entire data df. Okay, I might have 50,000 unique words. Okay, this is just an assumption. So you can take any kinds of assumption. I'm started with 50,000 because I saw like people are using 50,000. If you check different, let's say Kaggle notebook and all, people will be using 50,000. So this is the default size they assume actually, and this is the maximum length. Okay, this is the maximum length of my sentence, or it's the maximum length of the tweet. This one again is a assumption. Okay, you can take this two number at least by default. Then you need to call the tokenizer. Okay, you need to call the tokenizer from Keras. Inside that you need to specify the max word. Then you need to feed the data. Okay, so what it will return, it will return some of the number. Okay, it will return some of the number. Then what you need to do, you need to take this number and you need to do the two sequence. Okay, two sequence means it will give you the sequence. Okay, sequence matrix. Then after that, this sequence matrix will have some of the problem, because let's say here I'm having two sentence. Let's say I'm having two sentence called Bappi is my name. Okay, Bappi is my name. Okay, and let's say there is another sentence, uh, how are you? Now tell me, in the first sentence how many word I am having? In the first sentence how many word I am having? Please let me know. I'm having four word in the first sentence. Okay, and in the second sentence I'm having three word. Now whenever it will do the vectorization, so here how many vector you will get for each and every word? Four vector. Okay, but here you will get three vector. Now see, input size won't be matching, because here you are having four, here you are having three. Okay, so whenever you will give it as input to the model, it will throw error. It will throw error. I'm expecting four, but you have given three. So that is why you need to perform something called padding. I think you have learned padding, right? So let me give you one basics idea. Let's say you have two image here. So this is one image. So let's say this image size is 24 comma 24, and there is another image. Okay, there is another image. So this is a little bit smaller image. So this is, let's say 16 comma 16. Now here I have my model. Okay, so it takes actually 16 pixel, sorry, 24 pixel, dot 24 pixel. Okay, now this one I can give very easily, but whenever I will give this one, okay, will it work? Okay, it won't be working. So what you need to do at that time, you need to adding some padding. Okay, we'll be adding some extra pixel here. Okay, extra pixel, we call it as extra pixel. Okay, now it will become 24 comma 24. Okay, and these should be zero value only. This will be zero value will be. Now I can give this image to my model. Okay, so this is called padding. So in text also we need to add padding. So let's say here I'm having two sentence, my name is Bappi. Okay, so let's say this is having let's say four vector. So let's say any kinds of vector, 0 0.25, 0 0.55, 0 0.36, okay, or 0.46. Now let's say here I'm having four vector. Now there is another sentence, how are you? How are you? So here having three vectors, what I need to do, I need to, let's say this is the representation of it, 6, then 0 0.56, 0 0.77. Then at the last, if you see this word, there is an empty word. Okay, so this one you need to fill with 0, so that your input dimension should be matched together. Okay, so this is called padding. This is called padding. Okay, and how to perform padding with the help of this pad sequence. Okay, with the help of this pad sequence, it is available inside Keras only. Okay, you can do the padding operation. Now if I execute, you will able to see your data has become integer encoding. See, let me show you the sequence metric side. Now this sequence metric is nothing but your entire training data. See, now first of all it was in a text format, now it has become a number. Okay, but this number is called integer encoding number. Now again you need to train, these are the value. Okay, you need to train these are the value with the help of this embedding layer. An embedding layer will generate the actual vector of the text you have given. Got it? So how this thing will work? Let's say it will also contain the semantic information. Let's say you are here, you are having two words. Let's say king and queen. King and queen. So if you are using embedding layer, it will train. Okay, it will do the back propagation and all. Okay, during learning it will learn. Sorry, let me just draw it quick. Yeah. So during back propagation it will learn. So let's say king will come here. Let's say this is the king vector. This is the king vector. Okay, and automatically it will learn during back propagation, and it will also adjust the weight, and it will represent this queen vector also uh, near to the king. Let's say this is the queen vector. Is the queen vector. Now can I consider this king and queen is the same entity? It is representing in the same cluster. Okay, now let's say there is another word called monkey. Okay, monkey. So monkey is different entity, so it will come here only. Okay, it will come in a different cluster. Okay, cluster 2, this is cluster 1 and this is cluster 2. So that's how it can also represent the semantic meaning of the word. Okay, if you are using this embedding layer Keras embedding layer. Okay, so that's why it is better than your TF-IDF word to vec or bag of word. Got it? If you want to learn this embedding, so you can search about embedding and you can learn. Okay, so there are some theoretical topic inside that. I'm not going to go inside the theory. Okay, because this is the practical implementation I'm doing here. Fine. Now I will be defining the model. Okay, and I'll be defining my model architecture. So this is the architecture I created. So let me show you. This is the architecture. Now I need to import some of the library. So first of all, I need to import something called sequential. So let's import sequential from the Keras. Okay, then I need to import something called embedding. So let's import embedding also. So this is the I'm importing LSTM, activation, dense, dropout, input embedding, and sequential dropout. So these are the thing actually you need. Okay, then apart from that, what I need, I think I have imported everything. Okay, I need to import something called RMS prop. So let me import RMS prop as well. RMS prop is a optimizer. Okay, it's a optimizer. So this is optimizer. Now anything I'll need, I think I have imported everything. Dropout I also imported. I think, yeah, everything is fine. Yeah guys, everything is fine, I think. Okay, now let me import them, and this is my final architecture. So let me compile the model after the summary. So this is the model architecture, and here you can do the compile of the model. Now see guys, how I prepared the model. Okay, there is a question, what is the difference between sequential dropout and dropout? As I know dropout. See, this is like a little bit different, like dropout technique. So here in the backend, they're using some other equation. Okay, instead of the dropout equation, you can search about it, you will get it. Okay, because see, there are so many alternative. Let's say you are using this RMS prop. Okay, RMS prop. You have different RMS prop as well inside optimizer. Got it? Yeah. Now see, first of all, I'm defining the sequential layer. First thing you need to do the embedding layer. Okay, the first thing you need to do the embedding layer, because why you need to do the embedding layer at the very first instead of LSTM layer? Because you have the data, which is nothing but as of now integer encoding data. And here I am using something called embedding layer, embed layer. Okay, embed layer. Then after that you can take any LSTM layer. So first of all, embed layer, what it will do, it will convert your data to the vector. Okay, vector representation. Then it will pass to the model. Okay, then your model will learn, then it will give you the output. Okay, so that is why before initializing your LSTM, you first of all need to initialize the embedding layer. Okay, in embedding layer, 100 represents what value here? Okay, so 100 represents actually, it is telling, see, this is the max word. So here you have, I think, assigned the max word. I think you remember. Max word means you are telling I'm having 50,000 unique word in my entire corpus. Okay, then it is telling the vector actually will be representing. That means each and every word. So let me show you. Let's say there is a king. Here is a king. Okay, so this king vector I need 100 dimension. Okay, 100 dimension. Let's say 1 2 3 dot 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 100. Okay, so this one only represent king. So that means you are having 100 space. Okay, 100 space. Okay, 100 space in the dimension, just consider. Okay, but initially I have taken only 2 space, that's why it is representing as 2. But here I'm telling you should represent the king in a 100 dimensional space. Okay, that's why one vector would be in 100 dimension. That means it will contain the 100 value. Got it? Because if you increase the dimension, that means it can learn the king in a better way. Fine. Again, this number is a hyperparameter number. You can give any kinds of number. You can also give 50. Okay, or you can also give let's say you can also give, let's say, 20. You can start with any kinds of number. No, it is from entire corpus. Okay, 50,000 means you are considering inside the entire corpus of having 50,000 unique word. This is just an assumption. Then here you are giving the input length. That means the maximum length. Maximum length here you have defined. Okay, max length 300. Then after that you are adding one dropout just to avoid the overfitting. Then you are taking your LSTM layer. Okay, now see, embedding layer. What would be the output of the embedding layer? Tell me, what would be the output of the embedding layer? Like, what would be the dimension of the output? What would be the dimension of the output from the embedding? It should be 100 because here you have given 100, na? So one particular vector would be in 100 dimension. Fine. This 100 dimension will take your LSTM. LSTM input should be 100 dimension. But how do you know it's 100? We can give 200 dimension. Yes, you can give it. It's a hyperparameter tuning, Lincoln. Okay, here I have started with 100. You can also give 200. But I experimented with 100 and 100 was working fine here. That's why I kept 100. Because see, here we are creating our custom architecture. Now, whenever we are creating our custom architecture, so you need to do the experiment with different architecture. Which architecture will work fine? The same way you did in your CNN as well. Yeah, more dimension means more processing time. You are correct, Imran. Fine. But if you're using any pre-10 model here, let's say you are using Hugging Face model. Okay, if I go to the Hugging Face model, you have different transformer based model. At that time you don't need to consider these are the thing. Okay, see, let's say you want to perform something called text classification, na? So let's say text classification task is there. Now here we are having, these are the model: Roberta based model, distill BART model. Okay, then you have find BART model, then BART model. Okay, you have different models. See, so these are the transformer based model and these are the pre-trained model. Okay, you need to only download the weights and on top of it you need to fine tune. But here what we are doing, we are creating our custom architecture where we're training from it scratch. That is a different. Okay, that's why you have the flexibility to change everything here. Got it? Then after that, I'm taking one particular dense layer at the very last layer because it's a classification problem. Okay, whether it should be hit or no hit. And here I'm adding sigmoid activation function because I know I am having two classes only, hit and no hit. That's why you can take sigmoid activation function. But if you are having more than two classes at that time, you need to go with softmax activation function. Okay, then this is the summary of my model. And these are the trainable parameter, guys. Okay, these are the trainable parameter, as you can see. And you need to do the compile. I think you know, if you have already worked with Keras, you need to compile the model. This is the loss I'm using: binary cross entropy, optimizer, RMS prop, metric wise, accuracy metric. Fine. Okay. Now what I will do, I'll just feed the model. Okay, I'll feed the model with my data. So let's feed. So model dot feed. What is the data? Data is nothing but my sequence metric. Okay, as you can see, this the sequence metric is my data. And y train, that means this is my label. Batch size you can give. I have started with 128. Epoch, I'll only train one epoch. Okay, just to show you one epoch I will train. You can increase the epoch size if you are training your actual model. Validation split, you need to give some validation data as well, but I haven't given any validation data, so it will take the validation data from my training data. So I've given 20% data for my validation. Okay, now let me start my training. See, training has started. Now it will take some time because I'm having more data here, so it will take some time. And again, we have increased the dimension here, right? 100 dimension you have taken, so training time would be a little bit high. Okay, so that is why you need GPU. Okay, GPU training. And if you're training on CPU, so definitely it will take some time. So guys, so far everything is clear. Tell me yes or no. Are you able to understand? Like very simple code only, but only you just need some understanding on it. So this thing actually need to convert as a modular coding. We need to create as a pipeline. Again, epoch is depends upon the model learning. Okay, if model is learning better, you can increase the epoch. At least start with 100 epoch. Okay, this is the idea. By the time, can you please show the integer encoding part code before giving it to the embedding layer? Yeah, so this is the encoding in integer encoding part. First of all, you need to give it to the tokenizer. You need to feed to the tokenizer. Then after that, you need to convert to the text to sequence. Okay, it will give you the sequence metric. After that, you need to apply pad sequence on after. Okay, why pad sequence? Because some of the text will have more length, some of the text will have less length. That's why you need to bring all the length to like same. That's why you are adding some zero value. Okay, before or after. We call it as integer encoding. Yes, I'm going to use Keras. Okay, Keras library, TensorFlow Keras. Why we are not using advanced architecture of BART or GPT models, sir? You can use it, Lokesh, no issue. Let's say I can let's say there is a what, there is a bird. Okay, there is a, let's say, bird, bird, bird. Okay, bird. Let's say I can kill this bird with a let's say what, okay, with a, let's say, pistol. Okay, pistol, I can kill this bird. But to kill this bird, should I use rocket launcher here? Tell me, rocket launcher should I use to kill this bird? No, because I can kill this bird with a pistol. Okay, that's why I don't need rocket launcher here. So this is just a basics problem statement which I can solve using the LSTM only. Okay, why you are introducing BART here? Tell me. Because BART is like a very huge architecture, na Lokesh? So first of all, start with basics of like architecture. Okay, if it is working fine, then try to use it, because again, it includes cost. Okay, it includes training cost and all. Okay, so you need to take care. These are the thing actually. So always try to reduce the complexity, reduce the cost, the application you are creating. Let's say problem statement can be solved using machine learning algorithm. Then no need to come inside deep learning, no need to take inside LSTM. Fine. But whenever we have advanced, let's say, NLP task, let's say name entity recognition, chatbot, let's say text summarization, okay, at that time, these are the custom architecture won't be working fine. Then I need to go with transformer based architecture because their context is matter. Okay, that time you can use. Yeah, here self attention is not required because again you are doing a classification here only based on some word, positive and negative word, you are doing the classification only. So attention doesn't require here. Attention when you need, whenever you are getting conversational agents, text summarization, name entity recognition, at the time you need to understand each and every context of the sentence. That time attention is required. Lincoln. Got it? But for the classification, sentiment analysis, you don't need any kinds of attention. Okay, my training is almost done. Uh, and this is the accuracy I got. See, accuracy I got how much? See, 88% of the accuracy, validation accuracy 93. That means it's learning fine. Okay, see, with the help of this custom architecture, we are able to achieve a good accuracy here. Attention and self attention, again, it's a theoretical concept. Okay, I need to explain, but okay, in this session, I can't do it. So you can, I think, search okay on the internet, you will get the idea what is self attention, what is attention. Or I think I will create some video on top of it. Okay, yeah. See, training is completed. Now, what I will do, I also need to test the model, evaluate the model. For testing, evaluate the model, I also need to prepare my testing data. Okay. So the same thing I perform also on top of my trained data. I also need to perform on top of my testing data. As you can see, first of all, I need to apply the tokenizer and apply the pad sequence. Okay. Then my testing sequence would be ready. So this is my test matrix right now. This is my test metric. Okay. Now I'll evaluate the model. I want to see whether my model is working fine on top of my test data or not. So I'm just writing model.evaluate, and here I'm giving test sequence and my y test, and it will show you the evaluation metric. Would you describe the training cost of Scala, TensorFlow, PyTorch, etc. in terms of industry standard? See, sklearn doesn't need any GPU. Okay, so you can use sklearn for the machine learning purpose, so it doesn't have any cost. But whenever I'm talking about TensorFlow, PyTorch, so there you have something called GPU training as well. So either you can go with free GPU on Google Colab, either you can take some let's say cloud-based GPU, okay, or you can buy also instance. It depends upon how much like hour you are doing the training, how many hour you are doing the training. Okay, every instance is having their hour-wise price. You can visit these at the website. There is a website called Paper Space. Okay, Paper Space, Paper Space. So this is one website. So it provides NVIDIA GPU. Okay, so you can buy this GPU hour wise. So you can go with this website and you can see the GPU charges. Then there is another website called Data Crunch. So see, I got this is the loss and this is the accuracy. So if you increase the epoch size a little bit, you can achieve higher accuracy here. See, it is learning. That means it is learning. That means this architecture I have created, it's a good architecture. Fine. Now let's test my uh, now let's test my model. Okay, LSTM prediction. So I'm testing on top of my entire test data. Then I will use my prediction data. Okay, from the user. Which one is easy? TensorFlow, PyTorch in the JD. Most of the companies describe both. You should have knowledge on both. Okay, TensorFlow, PyTorch, both. But again, interest wise, as a developer, you will have the interest. Let's say personally, I prefer TensorFlow. Okay, but you might prefer PyTorch. It depends upon your choice. But both are good. Both are so powerful. But as a developer, you should have knowledge on both framework. Let's say if you are having some requirement for like with the help of TensorFlow or PyTorch, you can at least work on it. Then after that, I will write my prediction code. But before that, I can show you how to calculate the confusion metric. So this is the code for confusion metric. Okay, so first of all, here I'm separating out my prediction. That means if it is predicting, let's say, less than 0.5, then what I can assign, guys? Can I assign at 0? Let's say my model is predicting, because here I'm using sigmoid. What is the range of sigmoid? It will give you 0 to 1, right? 0 to 1 range output. Now let's say my model is performing less than 0.5. So can I consider this is as 0? Yes or no? This is as a 0. Or let's say my model is performing more than, okay, more than 0.5. Can I consider as 1? Okay, so this is my threshold. This is my threshold. Got it? So that's how actually here I'm written one threshold here. If my model is predicting less than 0.5, I will append it as 0, or else I will append it as 1. Okay, so this is the logic I have written. Now what I will do, I'll just do the confusion metric calculation. So again, you, I think, know inside sklearn we have confusion metric. Let me show you. Confusion metric, where it is, confusion metric, just a minute. Hmm. So confusion matrix, it is available inside sklearn. So here I can import from sklearn metric, confusion metric. Now if you give this prediction inside confusion matrix as well as your actual y levels, it will give you the confusion matrix. Now see, this is the confusion matrix. True positive, true negative, false positive, false negative. Got it? Now finally, you can dump the tokenizer. Okay, dump the tokenizer. So the tokenizer we have created, na tokenizer. I think you remember we initialized the tokenizer. We need to save this tokenizer. Why I need to save the tokenizer, guys? Tell me. Because whenever I'll be creating my user app, user will give what? User will give the English text. First of all, what I need to do, I need to convert the text to numbers. With the help of this tokenizer, I will be able to do it, na. But if I'm not saving this tokenizer, I won't be getting the tokenizer object, because this tokenizer is already trained, right? So that's why I need to save as a pickle object. So let me save this tokenizer. So here if you refresh, so tokenizer has been saved. See, tokenizer pickle, done. Now you also need to save the model, because this model you will be using for the prediction. So to save the model, you can use this particular code, model.save, and this is the name, model.h5. Because here I'm using TensorFlow format should be h5 model. For example, if we achieve the task using sklearn, then we don't have to go for GPU based library. Yes, first of all, you need to start with let's say simpler approach. Okay, if simpler approach is working fine, no need to go for, let's say, advanced part, or let's say higher approach. Got it, Muhammad? Because you need to always reduce the cost. Okay, that's why these are the simple problem statement. Always start with simpler approach. Hmm. Now after saving the model, I need to load the model. So I need to import the keras. Then I'll load the model as well as my tokenizer. See, that's how you can load keras.model.load, and you can also load the tokenizer with open. Okay, let me load. Then this is the final prediction code I have written. See, what you need to do first of all, see, before passing this thing inside your tokenizer, you need to perform some cleaning operation, right? If you having these kinds of quotation and all, so you need to clean. Let's say this text is containing HTML tags and all, you need to clean. So the same cleaning function, I think you remember the same cleaning function I written above. I think somewhere I written na cleaning function. The same cleaning function I just copy pasted here. See this cleaning function, cleaning data. Here I have given for the prediction. So the data actually user is giving. Let's say I love this movie. So this is the input I am giving. First of all, I need to clean it. Okay, as you can see, first of all, I'm cleaning. After that, I'm performing the tokenizer. Then after that, I'm doing the prediction. And here I'm showing my prediction. Okay, now let me execute and show you whether this text is positive or negative. Now see, I love this movie. Prediction no hit. Is it correct? Is it predicting correct? Yes or no? I love this movie. It is telling no hit. Yes. But before tokenization, we need to clean the text in the prediction pipeline. Yes, we are doing now. See, here is the function I have written, and here is the cleaning I am doing. Then after that, this text I am giving to my tokenizer. Got it, Lincoln? I have written everything in one cell now. That's why it looks like that. Now you can give any kinds of input text and you can do the prediction by yourself. Okay. Yes. So this is the entire notebook experiment we have completed. Now what I need to do, I need to convert this thing as a modular coding. I need to convert as a pipeline. Now what I will do, I'll just download this particular notebook and I'll keep it inside your project and I will push it to the GitHub so that you can practice later on. So I have already downloaded inside download experiment. I will move it while inside my project. So here I will create one folder and I'll just name it as notebook. And inside notebook, I'll give this notebook and let me push the changes to the GitHub.